All right. Good day, everyone. So I hope you're all doing well. So this will be the discussion for this week and next week. So I had put them together because they are continuous, and since this week we won't be meeting on the Wednesday due to an activity, so I have to fuse both discussions so you will better understand um, the concept itself. So, as promised, let's begin first with your formative assessment. So, let's start with level 1 and 2. Level 1 and 2 can just be seen from the graph. So, you can just directly get the answers out from the graph. All right. Now, for levels 3 and 4, you need to find patterns from answers in levels 1 and 2 in order, or you need to observe patterns in order for you to be able to answer questions in levels 3 and 4. And the answers are as follows. All right. For level 5 and 6, many of you actually got a mistake here. Maybe perhaps you didn't understand or you didn't really get what the meaning of discount is. Discount means that the amount becomes lesser. So if you're given a discount, say in a store, you the amount you are to pay would be much lesser than the regular or the original amount. So if you try to read this one, if somebody or if anyone avails the 3-day tour, then they will be charged a fixed cost, meaning the amount that they need to pay is fixed, and it's 150,000. 150 rather $150. That is if they are going to avail the promo for all 3-day tour. Now, however, the company offers a discount. So though they are to pay 150, which is fixed cost, every 10 miles they drive, there is a discount of $5. So you expect that the amount, which is 150, will still be reduced depending on how far they have driven. And that is $5 every 10 miles. So the moment they avail in this promo, they haven't driven yet. By the way, the independent variable here is the number of miles driven. And we can identify the total cost, the amount to be paid, after we know the miles driven. Thus, amount paid becomes our dependent variable y. Again, going back, the moment they avail on this promo, automatically they will be charged $150. That means 0x 150 for y. Now, how about if they were able to reach 10 miles? If that is the case, then the amount they're going to pay would not anymore be 150. But then there's a discount of $5 already because they have reached 10 miles. Thus, the amount they are going to pay would now be 145. Now, what if they were able to drive for 20 miles? That means they will be given a discount of $5 every 10 miles. 20 miles is equivalent to 2 miles. Again, 20 miles is equivalent to 2 miles. That means they will receive a discount of $10. Hence, for 20 miles, they're just going to pay 140. And this goes on and on. Okay? In other words, if you're going to plot this in the coordinate plane, the graph should look like this. All right? So that's 0, 150, 10, 145, 20, 140, and so on. So I guess only a few got this one. Hence, you really have to pay attention to details, read carefully, and try to see if it's increasing or decreasing. Sorry for that. Another considerations here is that you need to um, put labels in your x and y. It should not be x and y only. X is only a variable which represents a certain quantity. In this case, it represents the distance driven, which is in miles. Similar for the y, it represents the total cost in dollars. Now, there was also cases wherein you got the correct shape of the graph, but then the intervals here are wrong. So here, if you started with an interval of 5 in the x, it should be consistent. So 5, 10, 15, 20. You cannot say here you jump to 10, for example, without passing through 5. Just for example, you say this is 0, and then you went to 10, and then here onwards you have an interval of 5. So 0 to 10, and then here 15, here 20. So in that case, it's already a mistake. So make sure that when you started an interval here in the x, it must be consistent. Same is true for the y. Okay? And that's it. And of course, so this is actually the table of values. Of course, for questions 7 to 8, okay, the question is, what is the rate of rental? So actually, I have this one. Wait for. I have this erased. Let me just erase this portion here because this is not actually correct, no? So what is the rate of car rental in, let's say, the original graph? So if you try to go back to your original graph there, okay, you might be able to see that um, the rate of car rental is $5, meaning a $5 increase every 10 miles, or we say $5 per 10 miles. Now, in the graph that you created, you might be able to see as well that it's not an increase, but rather a decrease. So it's still $5 every 10 miles, but then it's a decrease of $5. That is why in symbols, we can use negative. So negative $5 per 10 miles. Negative means decrease. Okay? So for the linear equation to model, it's the same question asking like, how do you compute for the total cost if you know how many miles you've driven? So what if you have already returned from the trip and then you've already counted and calculated the number of miles? Say you have driven 80 miles, for example. So how much should you pay then? So that's actually the question. That's actually what's being asked here. How much should you pay then if you've driven 80 miles for the entire 3-day tour? Okay? So for you to be able to answer this question, you need to find a pattern. So if you try to look at it, we start with 0, x0, and then the cost is $63, for example. This is in the original graph, by the way. So looking at this, going to the next one, it's like you're adding 5 to it. Now take note that this is achieved by covering 10 miles. So you're adding 5. Okay, again, we're looking for a pattern. Now when you cover 20 miles, from 63, it's like you're adding 10. When you covered 30 miles, from 63, it's like you're adding 15. So here, find a pattern, find a connection. You may pause this video for a while and try to find a pattern. All right. So maybe perhaps some of you were able to notice that it's like adding $5 to 63 covering 10 miles. This 5 is simply half of 10. Similarly, covering 20 miles, you're adding 10 to 63 to get 73. This plus 10 is just half of 20. And of course, covering 30 miles, it's like adding 15 to 63 to get 78. 15 is like half of 30. So if you want to know how much we're going to pay when we cover 80 miles, it's like getting half of 80, and that's 40, and adding 40 to 63. So it's like plus 40 to 63, which gives us a total cost of 103. In general, to find the total cost, it's like getting half of the x, whatever the x value is, we get half of the x, in this case is 40, and that half will be added to the original value of the value of the y when your x is 0. Or in this case, it's just added to 63. Again, take 2. It's like to find the total cost, we just have to find half of the miles driven, whatever the miles driven is. Getting the half of it is being added to 63. In other words, the linear model we can create out from this is like y, the total cost, is just equal to half of your x, say 80, half of 80 is 40, and this 40 is added to 63. And this is now your linear model. All right? Similarly, for the second one, the same logic follows. The moment you avail for the promo, you are to pay 150. However, for every 10 miles, you get a discount of $5. So it's like 145. So covering 10 miles, it's like you have a discount of $5. Covering 20 miles, you got a discount of $10. And covering 30 miles, you get a discount of $15. How about covering 100 miles, for example? So again, looking into the pattern, it's like to get 145, we subtract 5. And this 5 is half of the miles driven, half of x, which is 10. So half of 10 is 5. Similarly, to get when you cover 20 miles, it's like you're subtracting 10 from 150 to get 140, and 10 is half of 20. So it's like half of 20, 10, and we subtract it from 150 to get the total cost. And the same reasoning for covering 30 miles. So if you cover 100 miles, it's like to get the total cost, it's like getting half of 100, which is 50, and subtracting it from 150, just like what you have noticed above. Okay? In other words, covering 100 miles, you are to pay 100. So again, the pattern here is like getting half of the x and subtracting such value from 150. Or in other words, the general equation would now be 150 minus half of your x. And you can actually verify both by trying to evaluate them at values 0, 10, 20, 30, 40, and 100. And if you try to evaluate the second one by those values of x, you will certainly get the y values, telling you that this represents this set of data. Okay? Now, normally, we write x first. So the one with the variable, we write it first. And the one without, which we call as the constant, we write it at the last. So we can actually revise this following that format, writing it as negative 1 half x plus 150. All right? Now, is there another way of getting these values? That is actually what we're heading into in the next weeks to come. For this particular week, we are after of knowing how does your y changes, just like this. How does your y changes for every unit change in x? And that is our goal for this week. So for this week, we have two goals. Number one is the slope or the gradient. So you need to understand what slope is, what it means in real life context, and of course, how do you graph linear relationships using the slope and using the y-intercept. Previously, you already know how to graph given table of values or ordered pairs, or even given a situation. From the situation, you create table of values, ordered pairs, and then you plot them and you connect the dots, you connect the points, and there you go. You already created the line. That is what we had before. But what if we don't create table of values? What if we know the slope, we know the y-intercept? How do we graph linear relationships? That is what we are going to discuss this week and next week. Okay? So part one of our discussion would be on the slope. Okay? For you to better understand the slope, let's go back to these situations. Okay? So the first situation is, or the one that we had in the formative. So what is the rate of car rental in the original graph? So we know already that the rate of the car rental is $5 per 10 miles. That's in the original graph. Meaning, there's an increase of $5 every 10 miles. While in your graph, it's negative $5 per 10 miles or a decrease of $5 every 10 miles. Again, if we create table of values for this, by the way, we have to make sure that you know which one is the x and which one is the y, the independent and the dependent variable. So here, independent is the miles driven, dependent is the total cost. So when we create a table of values for this, you have to ask yourself how the total cost y changes for each change in the miles driven. So this rate tells you how y changes for each change in the miles driven. So for example, if we start with 0.63, we know for a fact that every time we drive 10 miles, your Y changes or increases by $5. So this rate actually tells you how Y changes every time we change your X values. So the rate tells us that every 10 miles, your Y increases by $5. That means if we start with 0 and 63 for the Y, covering 10 miles, your Y should be 68. Where do we get this from? We get this from the rate, not anymore from the table nor from the graph. It's now from the rate. All right. Now continuing, covering 20 miles, that means we will increase the Y by $5. So it's now 73, and so on and so forth. For the other one, again, remember, if you take the promo, you're going to pay $150. But then the rate for the second table of value is every 10 miles, that's a decrease of $5. That means covering 10 miles, instead of having a larger value, it would be lesser by $5 rather. 20 miles, lesser by $5. 30 miles, that's 135, and so on and so forth. All right. In other words, these rates tell you how Y changes. The rate actually helps us determine the Y every time your X changes as well. All right. So for you to be able to understand further, no, the use of the rates, for example, in determining the Y for every change in the X, let's have some real life examples. Let's start with this one. So I believe your parents might be able to relate on this, especially those parents of yours who drives a car or a motorcycle. So right now, this is the rate of gasoline here in Indonesia. And let me focus with the Pertalite. So the Pertalite gasoline, by the way, your independent variable here is the amount of fuel, which is obviously in liters, and Y is the total cost that you're gonna pay. Now, to avoid a lot of zeros, let's say the total cost in 10,000 IDR or Indonesian rupiah. So every value I'll be giving here, it's in 10,000. So if I give 2 here, that means it's 20,000. If I give 20 here, that means it's 200,000 because it's in 10,000. All right? So if you try to look at it, the rate of the Pertalite gasoline as of the moment of speaking is actually 10,000 Indonesian rupiah per 1 liter. That's the rate. So knowing the rate, it's easy for us to come up with data because the rate tells us how your total cost changes every time you add in liters of fuel. Or for example, let's say you didn't avail any liters of fuel yet. That means you don't have to pay anything. However, the moment you avail for 2 liters of fuel, that means you're going to pay 20,000 Indonesian rupiah because the rate is 10,000 Indonesian rupiah per 1 liter. Now, sir, why is it not 10,000? Because this is 2 liters. Had this been 1 liter, then this becomes 1 or simply 10,000. But then, since we talked about 2 liters and every liter is 10,000, therefore 2 liters corresponds to 20,000 Indonesian rupiah. How about for 4 liters? What do you think? Great. This is now 40,000 Indonesian rupiah. $6, 6 liters, that's 60,000 Indonesian rupiah. 8 liters, that's 80,000 Indonesian rupiah. See, this is the use of rates. It tells you how to determine the Y or how the Y changes every time we change the X values. So we are in control of the X values, whereas the Y values depend on the X values. That's why we call this dependent and we call this independent. All right. Let's have another example. Let's talk about the fastest trains in the world. So according to this website by Omri, the fastest train is actually the maglev train in Japan. And according to him, the rate of the maglev train is 374 miles per hour. So for this particular example, let's try to focus with the maglev train. So again, the maglev train's rate is 374 miles per hour. So before we try to gather data, let's try to find first the independent variable and the dependent variable. So obviously, in this particular example, your independent variable is the time in hours, because this is miles per hour, and the dependent variable, the y, is the distance traveled in miles. So you will only get to know the distance if you know how long have you been driving. Okay? And the rate tells us that you are going to cover 374 miles every hour. Take note, 374 miles every hour. So if, and that's the rate, sorry, 374 miles per hour, per 1 hour. So if you haven't, if time is zero, for example, that means you haven't covered any distance yet. But the moment you have, you've been traveling for 1 hour in the maglev train, that means you already have covered about 374 miles. See, y value depends on the x. How about if you've been traveling for 2 hours? That means the distance you've covered is already 748. How about for 6 hours? So here, take note that we are actually covering 374 per hour. So if it's 6 hours already, that means we are already traveling a distance of about 1,122. Okay. By the way, I guess this is a mistake. Um, this should have been, let me just correct this one. I'm sorry. So this is not 1,122, but rather this is 2,244. Okay? All right. So that's 2,244 miles already. That is if you've been traveling for 6 hours. All right. So this is the use of rates to determine how y changes every time you change the x. Let's have another example. All right. Let's say we look into the average daily deaths in the United States by cause from 2020 up until present time. So let's focus on the reason, which is COVID 19, the pink one. Um, Respiratory reasons, COVID 19. Okay? And to be more specific, I'll focus on this particular area. All right, this one. Now, in April 2020, deaths in US reached approximately 2,000. However, due to more people getting vaccinated, mortality rate means death rate, went down to 150 deaths every 5 days. Okay? So if we try to look at it, this tells us that the mortality rate is going down to 150 deaths every 5 days. So obviously, here we are comparing about the number of days and the number of deaths. So our independent variable is time in days, and the dependent variable is number of deaths. And according to this, the rate is 150 deaths every 5 days. Okay? Since it's when going down, it went down, therefore the rate is negative. Okay? Because it's going down, meaning it's decreasing. So negative 150 deaths per 5 days. So from here, we could already gather data. All right? Saying that at the beginning, there are 2,000 deaths. But since we have a rate of negative 150 per 5 days, so we expect that after 5 days, the number of deaths has gone down to 1,850. Now, just to clarify, it doesn't mean that from 2,000, it's now 1,000 850, the 150 has resurrected. No, it's not the meaning. It's not the this is that is not what it means. It only means that at the beginning there are 2,000 people who died, but then after 5 days, the number of deaths has gone down to 1,850. Still, it's too many. It only means that from 0 to 5, there are 3,800 people who already died. But looking at the positive side of it, it's not as many as the 0th day because now the rate has gone down to 150 every 5 days. So instead of having 2,000 people dying every day, after 5 days, it went down to 150. Thus, we only have 1,850. So after 10 days, the number of deaths is 1,700. 15 days, 1,550. And 20 days, it's 1,400. So this is the use of the rates. It enables you to determine the y values every time you change the x values. Alright? Now this time, let's now go back to the idea of the rates. And let's try to further understand how do you determine the rates? What's the meaning of the rates? So if you try to look at it, the rate usually is given in terms of quantity over another quantity. So if you try to inspect it in both rates given, the one on top, the numerator is mostly the y quantity or the dependent quantity, whereas the denominator is the independent quantity. All right? In other words, the rate of change, we're talking about the change rate. What is the rate of change? We're talking about the change in the y over the change in the x. So this is actually the dependent quantity, and this is actually the independent quantity. And it's not simply y over x, but it's change. This triangle means change. The change in y over change in x. So we're looking into the rate. How does your y change for every change in the x? And this is what rate of change is all about. For example, for you to be able to understand it properly, let's try to focus on these two values in the table of values for the first one. Okay, so in this table of values, we can see that for the amount of fuel, um, it's from 40,000 going to 60,000. Okay, that's the y. That's how the y changed from 40 to 60,000. That is every 2 liters of oil that you avail. So of course, your x also here changes by 2 liters. Again, take 2. Here we can see that your y changes by a certain amount due to the fact that your x changes as well. Okay, so if we try to put it in here, it's like 60,000 minus 40,000. Why? Because we wanted to know how your y changed from 40 to 60. How much is the increase, in other words, from 40 to 60,000? So for us to know the increase, for us to know the change, we have to subtract 60,000 by the previous, which is 40,000. Take note here, we started with 40,000, it increased to 60,000. So 60,000 is the current, 40,000 is the previous. So to find the change, it's current minus previous. So 60 minus 40,000. And then for the x as well, we need to know how it changed. So that's 6 minus 4. Thus, we have 20,000 over 2, giving us 10,000, which is actually the rate of change. So we say this is 10,000 rupiah per liter. Take note that our quantity, the quantity is y here is your total cost. The quantity x here below is your number of liters. So we say 10,000. This tells us the amount you're gonna pay per 1 liter. All right. Now for the table of values below, we can pick these two values here, and we can see here that in terms of number of deaths, it is 1,550 going to 1,400. So this 1,400 is your current value, and this is your previous value. And we wanted to know how this changed based on the change in the x as well, from 15 days to 20 days. So using the same method that we have here, so it's like 1,400, the current, take note it should be current minus the previous 1,550. And this happened in a span of 5 days, which is calculated by subtracting 20 days by 15 days. So we know how long it took from 15 days to 20 days. All right? So simplifying it, we get negative 150 over 5. So we have a negative here because this is a decrease from the current to the previous. And thus we get negative 30. Okay? You might be asking, why is this negative 30? Here it's negative 150. So if you try to look at it, um, here the rates of change actually answers the question how y changes for each change in x. So how does your y changes for each change in x? The moment you get the rate of change, this rate of change can be interpreted as 1,000 Indonesian rupiah per liter. In other words, we can interpret it as the total cost increases by 1,000 Indonesian rupiah per liter. Okay? So this rate of change therefore tells you how the amount or the total cost increases every liter of gasoline added to your vehicle, for example, or for every liter of gasoline that you avail. Okay? Now, for the second one, this negative 30 can be interpreted as, by the way, you might be asking, why is this negative 30? Now, this is negative 150, that's per 5 days, but since this is just a ratio or a fraction, we can actually simplify it further by dividing negative 150 to 5 to make it a lot easier to understand. So negative 150 divided by 5, that gives you negative 30. That means it's another way of saying that there are negative 30 deaths per 1 day or per day. Okay? So instead of looking at it in 5 days interval, we can look at it in a much simpler 1 day interval to make it a lot easier to understand. In other words, this can be interpreted as negative 30 deaths per day, or the number of deaths decrease by 30 per day. And this is what rate of change is. In linear relationships, rate of change is actually known as the slope, or simply the gradient. Alright? This is where the concept of slope comes in. Slope therefore tells you how y changes for each change in x. And in linear relationships, slope should be constant. Slope should be consistent, same value all throughout. So for the first one, the slope is 10,000. In the second one, the slope is negative 30. And these are the interpretation. So moving forward, we're going to identify and find, or we're going to know, you are going to know how to find the slope given different situations, and also how to interpret the value of the slope. Going back to our previous example here, so if you try to look at the formative assessment, so in this case, this will also explain the negative 30 that you saw a while ago. Here in the original graph, you have $5 increase every 10 miles. So it's like change in y over change in x, which simply says that the change in y is actually $5, which is an increase. That's why it's positive. And then for every 10 miles in the x, that's why the change in x is 10. Again, we can simplify this. Since it's just a ratio, we can actually reduce this to a much simpler term, which is 1/2, or simply 0.5. In other words, we can interpret this as half of a dollar every mile, meaning the cost of the car rental is simply half of a dollar, or say 50 cents every mile. Or another way of looking at it, we say the amount of car rental increases by half of a dollar every mile traveled. Similarly, in the second situation, we could still look at it as change in y over change in x. Since it's a $5 decrease, therefore your change in y is negative 5 for every 10 miles. Simplifying it, we got negative 1/2 or negative 0.5. So this can be interpreted and analyzed as negative half of a dollar or negative 50 cents every mile. In other words, the amount of car rental in your graph decreases by half of a dollar every mile traveled. And this is the use of the slope. Okay? So let's now learn how to find the slope given different situations. First, finding the slope given a table of values. Say the table shows the speed of an encoder in words per minute, WPM. So these are the speeds. So looking at it, your independent variable x, since we're talking about the speed of the encoder in words per minute, this tells you the time that the person is working, and your y tells you how many words are being encoded. In other words, your x is time and y is the number of words. Now the slope or the rate of change is simply the change in y over the change of x. So for us to know the change in y and the change of x, we have to choose two data out from the table of values. Let's say we use this data here, 7 minutes and then 140 words, 12 minutes and then 240 words. So here, we need to find the change in y and the change in x. So the change in y would be how much is the change from 140 going to 240? How much, in this case, is the increase? Because the previous is 140, now it's 240. So how much is the increase? Similarly, it's from 7 minutes to 12 minutes. So how long did it take to see this particular increase? So we have to find the change in y and the change of x. Change in y will just be 240, the current minus the previous. 240 minus 140. And then for the change in x, it's 12 minus 7, which gives us 100 over 5 equal to 20. In other words, the rate of the person in encoding is 20, which can be interpreted as 20 words every minute. So this is now the rate of the person. That's 20 words every minute. Or this 20 tells us the number of words encoded, or we say the number of words encoded increases by 20 every minute. All right? And this is how to find the slope given table of values. So from here, we could continue making the table. Take note that it means every minute, the person can encode 20 words. So after 1 minute, say from 12, we go to 13 minutes. That means this y value should increase by 20. Thus, this becomes 260 words already in a span of 13 minutes. How about 15 minutes? Now from 13 to 15, that's about 2 minutes. And since every minute, this is 20 words, therefore from 13 to 15, he was able to type in an additional of 40 words. Again, the rate is 20 words per minute. Now this one is having a span of 2 minutes. Therefore, there should be an increase of 40 words from 260. Thus, we got 300 words. You may pause this video, try to copy down notes, or you may try to replay some of the parts. Now, how about if we have this particular example, a table only? You're given a table. So find the slope and complete the table. Now, in this case, we don't know what quantity x is and what quantity y is, but then we are still given the same instruction, which is to find the slope or the rate of change. So in this case, to find the slope or the rate of change, we have to choose two data from the given table. But when we do that, it's better for you to know how, or to have a general idea of how to find the slope. Or what do you mean by change in y and change of x? Change in y over change in x is simply the same as subtracting the current minus the previous. That's why we call it y sub 2, because y sub 2 means the second y coordinate, the current one. Obviously, you have a data, and after how many minutes, for example, there is already a change in the y value. That means this is the current minus the previous. Similar for the x, the current minus the previous. So here we have to choose y values. Let's say we use this and we also use this one. So you can choose any y or x values, but in this case, let me just use the ones that I have here. So in my choice, this is my second y, and this is my first. This is my current. This is my previous. Now, for you to know which one is the current, which one is the previous, it must go along with the x. It must be from left to right, or it must be increasing values of the x. So it's based on the x values. So here, this one is of a higher x value. Therefore, this must be my current, and this must be my previous. So this would now be 70 minus 35, and then 10 minus 5. So subtracting 70 by 35 gives us a change in the y. Subtracting 10 by 5 gives us a change in the x. Therefore, we get 35 out of 5, or simply 7. This is now the rate of change, or simply the slope. So we can interpret this as the dependent quantity, whatever that quantity is, since it's positive, increases by 7 every unit increase in the independent quantity, which is the x. So every unit that the x is changed, y increases by 7. So for example, if we are to continue this table now, from 10 to 14, our x increases by 4 units. Since every unit y increases by 7, therefore an increase of 4 in the x gives an increase of 28 in the y. Since every unit there's an increase of 7 in the y, so since we have 4 units here increase in the x, meaning x increases 4 by 4 units, therefore y undergoes a change or an increase 4 times as well. And each time y increases, it increased by 7 units. Therefore, the total increase in the y is now 28 units. Hence, if your x is 14, y would now be 98. Similarly, if your x is 17, from 10, it increased by 7 units. That means your y increased by 7 times as well. Because each time x increases, y increases by 7. Since x increases by 7 units, therefore the increase in y is 7 times 7, which in this case is 49. Therefore, if your x is 17, y is 119. You may take down notes, pause this video, and try to understand what this means. Now, how about for this particular example? Again, if you are to find the slope, so we need to know the notation. It must be change in y over change in x, which is just simply y sub 2 minus y sub 1, meaning the current minus the previous. Okay? So we just have to choose two x and y values here. So let's say we'll choose this one. Pause this video and then try to solve it on your own first. Alright? Again, for us to know which one is the current and which one is the previous, it's according to increasing values of the x. So since this is a greater x value, therefore this must be my current, this must be my previous. Alright? Hence, to find the change in y, it must be negative 10 minus 5 and then 7 minus negative 2. Okay? Simplifying it using laws of integers, we now have negative 10 minus 5 over 7 plus 2, which gives us negative 5 over 3, or negative 15 over 9, but then this can be reduced, so we have negative 5 over 3. Hence, we can actually interpret this as the dependent quantity y decreases by 5 every 3 units. Now, if we try to simplify this and make it a decimal, the value will not be exact, by which it's quite difficult. Unlike the previous one, wherein we have 1/2, which is equal to 0.5, we know for a fact that 0.5 is easy to interpret, easy to understand. So if you have 0.5, that means every change in the x, y changes by 0.5. And it's easy. So if, say for example, if your x is 1 and your y is 4, the moment x becomes 2, y becomes 4.5. Because the change in the rate of change is 0.5. In this case, since this is 5 over 3 and it's difficult to have it into a decimal because the value is not exact, we can just retain it as a fraction. But then this we can interpret as for every 3 units increase in the x, y decreases by 5 units. I repeat, we're using now here in the reference to 3 units in the x. So for every 3 units change in the x, y decreases by 5 units. Okay? So if we try to apply that here, if your x is now 10, that means from 7 it increased to 3. Therefore, your y should decrease by 5 units. Therefore, your y value is negative 15. Similarly, if your x value here is 16, from 7, it actually increased by 9 units. Since every 3 units, y decreases by 5, therefore this one, the x value here undergoes um, 3 units changes because it's 9. Therefore, it undergoes or it changes by 3 units 3 times. I repeat, the y value here, the x value here, changed by 3 units 3 times as well. Hence, your y should be decreased by 5 3 times also. Then, you have negative 10 minus 15, and that gives you negative 25. And that's how to use um, the rate of change for completing the table of values. Pause this video, copy the notes, and try to understand what it means. All right, this time, let's proceed. Okay, this time let's try to find the slope using ordered pairs. So suppose you're given a graph and you're asked to find the slope. The slope can be derived from the graph itself in two different ways. The first way is using the ordered pairs. So to use the ordered pairs, all you have to do is to know first what x and y is. So in this case, x is the distance in miles, y is the cost in dollars. All right? So find the slope and make a table of values. So here we can find the slope by first identifying 2 points on the graph. So in this case, these are the 2 points. All right? So the coordinate of the first point is 4, 11. The second point is 8, 19. Okay? Again, previously, to find the slope, we need to find the change in y over change in x, which is simply y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember that we need to know which one is the current and which one is the previous according to increasing values of x. Obviously, according to increasing values of x, this one is the current, this one is the previous. Therefore, in order to find the slope of this must be the y sub 2, and this must be the y sub 1, x sub 2, x sub 1. So we can now solve for the change in the y, which is 19 minus 11, the change in the x, 8 minus 4. Simplifying it, we got 8 over 4, or 2, by which we can interpret this as this particular rate of change 2 is simply telling you that you are charged $2 every mile, or the cost increases by $2 every 1 mile. So if you are to create a table of values for this, we can now say, based on this graph, um, if you haven't reached any mile, you are already charged of $3. Perhaps this is the flat rate of the taxi, meaning the moment you board the taxi, the moment you hire the taxi, you're supposed to pay $3, even without reaching any mile yet. But then every time you increase by 1 mile, the amount that you're gonna pay will also increase by $2. That's why after 1 mile, you are now charged by $5, 2 miles, $7, $3, 3 miles, $9, and so on. And this is how we find the slope using ordered pairs. All right? How about for this one? So similar thing, X here is the time in hours, whereas Y here is the temperature in degrees Fahrenheit. So we know already that we need to find 2 points here. Let's say this is the first point, this is the second point, and we need to find the change in Y over change in X. Again, according to increasing values of X, this is be our second point. That's why we call this your X sub 2 and Y sub 2, and this must be the first point, X sub 1 over Y sub 1. Take note, this is the current, this is the previous. This is according to increasing values of X. So according to the time, this is the current, and this one happened in 1 hour, the previous. So to find out the values of the change of X on Y, the change of Y over change of X, so we have to subtract the Y values starting from Y sub 2 minus Y sub 1, and then X sub 2 minus X sub 1, which gives us negative 2. So from here, we could already interpret this as there is a negative 2 degree Fahrenheit temperature every hour, or we say temperature decreases by 2 degrees Fahrenheit every 1 hour. So coming up with a table of values for this, so at 0 hour, temperature was at 82 degrees Fahrenheit. But then, since the rate is negative 2 degrees Fahrenheit every hour, that means every 1 hour, the temperature drops down by 2 degrees Fahrenheit. All right? And that's it. And the third, which is the last way of finding the slope, is by getting it out from the graph directly. Okay, remember that in this example, we were able to find out the slope by getting the change in Y over change in X using the coordinates or the ordered pairs. Now, there is another way of finding the slope without actually determining the ordered pairs, and that is by looking into how the Y changes every time the X changes. Okay, for example, let's try to focus on these 2 points. Now, since they are coming from the same line, therefore, your rate of change here should still be negative 2 degrees Fahrenheit. So we are going to show that the rate of change is still the same, but using a different method. Okay? And how is it found? How is it done? Again, it just revolves around the concept change in Y over change in X. So you have to know how much Y changes every time X changes. Okay? So to know the change in Y over change in X, it's like going from this point to the second point, which we have determined. So from this point to this point, we have to travel a certain X. You have to know how much is the change in the X unit along the X. So here, from this point up until here, it's like you are going to travel a certain X value. Now, for you to know this one correctly, you have to know as well the interval here in your x-axis. So here in the x-axis, every 2 interval is equivalent to 1 hour. So there is something that you have to be careful with. So it's not like 1, 2, 3, 4. You don't count it that way. It's based on how you have labeled your x-axis. So in this case, every 2 interval, that's equivalent to 1 hour. Therefore, this is 1, 2, 3, 4. That means there is meaning the change is 4 units positive. Since it's going to the right, therefore it's positive 4 units. Okay? From here, we try to determine what is the change along the Y component, meaning going up or going down, which in this case is going down. So for you to know what is the change, you have to know the interval along the Y-axis. So the interval here is 80, 79, 78, meaning it's 1 only. Since it's going down, therefore, this must be negative. So the change in the Y is negative. How much? 1, 2, 3, 4, 5, 6, 7, 8. That's actually negative 8 units. Or 8 units down. So without writing the word down, you can just write the symbol negative, meaning negative 8. Therefore, from the graph alone, we were now able to find the change in Y over the change in X without subtracting, without the ordered pairs. So we now put it in here, negative 8 over 4, which still gives you negative 2. And that's how to find the slope from the graph. Let's have another example. Here in this example, we found out that the slope is $2 every mile, or simply 2. So from the graph alone, if you wanted to find the slope, you have to choose 2 points and determine the change in the x over the change in the y. So this is the first point, this is the second point. Remember, this is the previous, this is the current. So we have to know from the previous to the current, how much is the change in the x. So the change in the x is actually about 6 units because every interval that's equivalent to 2 units according to the x-axis, 2, 4, 6. Since it's going to the right, therefore it's positive 6. Here, for the y, we need to know how much is the change in the y. In this case, it's going up. Since it's going up, this must be positive. Now, in the x-axis, if you try to look at it, it's actually having an interval of 2 as well. Okay? So since we are here in the middle, so we can just say this is 1 here, or this is from 0. So this is 2. Also the middle one above, 4, 6, 8, 10, and then 12. Or if you have another way of determining the change here, it's all up to you. But if you try to look at it, it's like this to this, it's 2. From this one to the middle of the other, that's 4. That's another 2, that's 4 already. 6, 8, 10, and 12. Therefore, the change in y is positive 12, giving you a change in y over change in x, which is 12 over 2, or simply 2. And of course, this will be our last example. Find the slope and make a table of values. Same process, identify 2 points here. All right. From the 2 points here, we try to determine the change in x over change in y. All right. So from the first point, going to the second point, so we need to determine how much is the change in the x. Looking into the interval, every 2 intervals here, it's like 5 units, meaning each interval is 2.5. So you just have to count how many 2 intervals we have here. So this is 5, another 2, 10, another 2, 15, 20, 30. Since it's going to the right, that means it's 5, 10, 15, 20, 25 only, sorry. So that's 25 units, a change of 25 units. From here, we go down. Since we go down, that means the change is negative. So we have to know the interval along the y-axis. Here, it's different. For every 2 intervals, that's 50. In the x, it's 5. In the y, it's 50. So we have to count, this is 50, 100, 150, 200. Meaning, since it's going down, there is a change of negative 200 units. So to find the slope, that will now be change in y over change in x, or simply negative 200 over 25, or simply negative 8. So this particular slope can be interpreted as the different quantity y decreases by 8 every unit increase in the independent quantity. Meaning, every time you increase x by 1, y decreases by 8. Such that if x decreases by 5, if x increases by 5 units, every unit, take note, it's negative 8, right? It's every unit change in the x. Therefore, if x increases by 5, y should decrease 8 by 8 5 times as well. That means a decrease of negative 40. So for 5, this must be about 560 rather, 560, because a decrease of 40 units. An increase of 10, meaning y decreases by 8 10 times. So this must give you a decrease of 80. So 10, you must have 520. Okay. And so on and so forth. And that's how to find the slope. Now, if we create table of values for this, 0, 600, 10, 520, 20, 440, meaning your y decreases by 8, 10 times for this, 20 times for this, 30 times, 40 times. Because this negative 8 is a decrease in the y every unit increase in the x. Similarly, find the slope and make a table of values. You can pause this video, try to do it on your own first, and then check later on if you got it right. Choose 2 points, okay? And then determine the change in the x and the y. So here, the change in the x, since along the x-axis is just a matter of 1 unit, that's 6 units. For the y, since it's going up, therefore we expect it to be positive. Now in the y-axis, every two interval, that's about 250. The change is, the interval is equivalent to 250. For every two intervals, it's equivalent to 250 units. So we count 1, 2, 3, 4, 5, 6, meaning it's 1 to 50 units. Rather, here, every change in the y, that's about 125 units. So if you try to look at it from 0, this is 125. Every 2, that's 250. All right? Therefore, this must be, not, this is not 1 to 50, I'm sorry. So I guess we got a mistake here. This is not actually 1 to 50. In other words, this is just about 750 units. Okay? So the change in y is just about 750 units and not 1 to 50 units. All right? So if we continue, I'm sorry for that. So if you try to count it, there are actually every 2 units here in the x, in the y, that's 250 units. So this is 250, this is 500, this is 750. So that must be 750 over 6, or simply 125. In other words, since we know what x and y stands for, so we can now interpret it as such: 125 meals packed every hour, or say the total meals packed increases by 125 every 1 hour. And that is the rate of change, or simply the slope. All right? And coming up with a table of values, so if they haven't started yet, meaning they haven't packed anything, after 1 hour, there's 125, 2 hours, 250, 3 hours, 375, 4 hours, 500. Okay? Now, to finish this part one of the lesson, so if you try to look at this one, if you try to notice it, if your slope is positive, your graph actually looks this way. In other words, it's increasing. Okay? Y values is increasing. It's going up. In other words, a positive slope leads to an increasing graph from left to right. So Y value increases from left to right as well. So we call this an increasing graph because Y value increases from left to right. However, if your slope is negative, you could actually observe that y value decreases. And from the graph, you could actually see a decreasing graph. In other words, a negative slope leads to a decreasing graph. It's going down. So y value decreases from left to right if your slope is negative. And this is actually the answer to your formative assessment, the last question. So observe the value of the slope, that with the shape of the graph. So if you have a positive slope, you expect an increasing graph. If you have a negative slope, you expect also a decreasing graph. And this is how a decreasing graph looks like, and this is also how an increasing graph looks like. Okay? And that's it. So you may pause this video, copy the notes, and try to replay if there are things that you were not able to understand. This time, let's now go to the last portion of this video, which is on y-intercept and graph linear relationships using slope and y-intercept. All right? So let's start with graphing using the slope. So let's say the speed of a car is 3 miles per hour. Produce a linear graph to show the distance covered every hour. So basically, we can graph this if we have table of values, and we can create table of values out from this as well. But what if we use the slope in order to produce the graph and not the table of values? First, identify the x and the y quantities. So obviously here, because the graph is being labeled, so x represents the time in hours, and y here represents the distance. Okay, so this represents distance. Okay, so basically here, um, time should be independent, distance should be dependent. All right. So if you try to look at this one, it's given here that your slope is 3 miles per hour. In other words, the rate of change is 3 miles. You will cover 3 miles every hour. So if you put it into the notation, change y over change in x, 3 miles every 1 hour, it's like having a quantity change in miles over change in hours, or say 3 over 1. In other words, the slope is 3 miles indeed for every hour. The question is, how do you start? How do you use the slope? To use the slope, we need to have a starting point. And for you to know what the starting point is, you must answer this question. How far have you traveled in 0 hour? So if you try to analyze, if it's 0 hour, that means you haven't traveled anything yet. That means you've covered 0 miles as well. Thus, from here, we can come up with 1.0 comma 0. And this question actually talks about one concept, which is what we call as the y-intercept. All right? So before we proceed, we have to learn first what y-intercept is. So y-intercept actually answers the question, say for instance, in this tank, in the first graph, what is the temperature in 0 hour? Anyone? Yep. Based from the graph, it's 82 degrees Fahrenheit. For the second, and from here we could actually create, or we can identify the table of the ordered pair 0, comma 82. For the second graph, how much is the cost if you cover 0 miles? Here the cost is $3. Again, we can have this from the graph 0, comma 3. In other words, y-intercept then is actually the value of y when your x quantity is equal to 0. Whenever you ask a question of what is the value of y if your x is 0, or what is the how much do you pay in 0 hours, um, let's say, how much are you gonna pay if you avail 0 liters? So whenever you ask that question, the value of y that you get, or your answer itself, which is just simply the y quantity, is what we call as the y-intercept. That's the value of y when x is 0. It's represented by the ordered pair 0, comma y. This ordered pair is not the y-intercept, but the y value is the y-intercept. The y value when your x is 0. And if you try to look at it, in the graph, it lies on the y-axis. So each time your graph crosses the y, the intersection, that coordinate or that ordered pair actually contains your y-intercept. All right? So going back here, let's just change this one. Okay. So going back here, we now have your y-intercept, which is at 0, 0. Okay, because in 0 hour you were able to cover 0 miles. Now, how do you create the line graph? To create the line graph, we need to use the concept of the slope. Remember, your slope is every 3 miles, or every 1 hour you covered 3 miles. In other words, every time you spend 1 hour, the change in y is actually 1, and the change in x rather is equal to 1. The change in y is equal to 3. That means every 1 hour here, you actually cover 3 miles. And that's where your second point is. I repeat, every 1 hour you cover 3 miles. Every 1 unit in the x, by which x is simply the time in hours, you cover 3 miles. Now, similarly, if we continue from this point onwards, the slope is still the same, meaning for every 1 hour you cover 3 miles, and that's the next point. So the idea here is to locate the next points. You need to have a point which we started from the y-intercept, and then onwards from the next point going to the next, we just do the same process using the slope. So to continue here, from this point already, the slope is constant, the slope is the same. Therefore, we say for every 1 hour, we cover 3 miles. And if you're already contented with this, you could already create or connect them using a line, and that's now the line graph. Thus, you are now able to produce the line using the slope and the y-intercept. Pause this video, copy down notes for you to be able to understand further. Let's have another example. Let's say in a week, your allowance is 560,000 Indonesian rupiah. Your average daily expense is at 80,000. Produce a linear graph to show the money left and the days passed. Okay. First, we identify the x and the y. Obviously, x is time in days, y is money left. But since it's about 560,000, 80,000, let's make it in 10,000 Indonesian rupiah. Okay. Now, let's find first the slope. So slope here, if you try to look at it, is your average daily expense, which is at 80,000. So we say slope is negative 180. It's negative because it's expense, meaning your money decreases by 80,000 every day. Since it decreases, we can just write it as negative. We can write it as a negative amount. So negative 80,000. So there is a decrease of 80,000 per day, or we say it's 80,000 per 1 day. Okay? So this is now the meaning of the slope. So you have to know how to identify and interpret the slope. The slope here, negative 80,000, means a decrease of 80,000 every day. And of course, for us to know where to begin, we have to find the y-intercept by asking ourselves a question: how much do you have at the start? Here, it's very obvious from the story that we have 560,000 Indonesian rupiah. Alright? So this will give us 1 point, which is 0,56. You might be wondering, why is it only 56? Because we said it's in 10,000. Okay, to remove the outer zeros. So the first point now is 0,56. Now, take note, to find the next point, we have to interpret the slope. Slope says, by the way, this is negative. Okay, so this means negative 80,000 per 1 day. In other words, after 1 day, by the way, if you try to look at it, I changed my interval. Every three intervals here, that's equal to 1. So every 1 day, okay, my money decreased by 8 units, or simply 80,000, because it's every 10,000. That means that's now my second point. The next day, my money decreased by, again, 8 units. That's my third point. Again, in the next day, in the next day, which is 1 unit, which is 1 day, my money decreased by 8 units. In other words, once you are convinced about already that this can already form a line, you can now connect them, and then you were able to form the linear graph. All right? Finally, let's have one last example. Create the graph of a linear relationship given that m is equal to negative 3/2 and y-intercept is equal to 7. By the way, you can pause this video, replay if there's a need. All right. So here, your m is given as negative 3/2. How do we interpret it? Since it's a fraction, we can just say there is a decrease of 3 units every 2 units in increase in x. There's a decrease of 3 units in the y every 2 units increase in x. Or we can say there is a change of negative 3 units in the y every 2 units increase in the x. Now, for us to know where to start, we have to know how much do you have at the beginning. What's the value of y when x is 0? Here it's given that the y-intercept is 7. Therefore, we have 7. Since our y-intercept is 7, that is what we have at the start. Meaning, at 0x, y is 7. And we have to plot it here. So, it's actually this. All right. Now, to find the next point, we just have to interpret the slope. Every 2 units in the x, y decrease by 3 units. That's the next point. Again, every 2 units increase in the x, going to the right, that's increase. Y decreased by 2 units, 3 units. Every 2 units increase in the x, y decreased by 3 units. And if you're confident with this already, you can now find the other points and connect them to produce the graph. And this is how you graph linear relationships using slope and y-intercept. Now, you might prefer the table of values because you're used to it already. However, there are instances wherein this is a lot easier to do, especially if you get used to it already, rather than having table of values. So I'd like you to just simply study on this, copy down notes, and I'll be giving you exercises on Monday. You don't have to really study everything. At least you're able to do a portion of it. And we will do exercises on Monday. All right. Thank you so much, everyone, for listening, and see you in class.